Right, welcome. My name is Mahmoud Abdelghany, and I'm gonna tell you some stuff about my project, porting Doom 3 to Java. First, I have to apologize. I have a bit of a cold, so if you can't understand me, it's because I have a cold. And incidentally enough, last time I gave the talk, I also had a cold, so I think it's related to the talks, whatever. So where to start the talk? So I'm gonna start the talk with a boring intro, because every talk needs a boring intro. But there's a point to this intro. You will understand after I'm done with it. So first of all, id Software is the company that actually created Doom, the actual game. They're a very unusual company. They always did very interesting stuff, you know, groundbreaking stuff, legendary stuff, like people say nowadays. These are some of the games they did. You know, Commander Keen, for example, it's 2D game. At the time, they did 2D scrolling, smooth 2D scrolling on the computer, which was next to impossible to do, actually. Sorry, so this was 20 years ago, something, and it was very interesting. Some other games. The most interesting thing they did, for me at least, is they open sourced almost everything they do, and that's very interesting. And everything's been ported, and especially Doom. And there's somebody here from a team called Doom Anywhere. And those are the guys that port Doom literally to anything. They ported the original Doom to toasters, washing machines, lately to that touch bar thing from the new Macintosh and stuff. So it's the most ported game on the planet, I think. The original Doom, at least, not this one. So these guys, they started 20 years ago. There was a very small team. Nowadays, you would call this an indie studio, an indie development team, or something like that. And at the bottom, this table, this shows a bit of the evolution of their engines over time. So Doom, the original Doom, well, I think is 91 or something, 1991. Something like, I don't know, 40,000 lines of code, and then 150,000 lines of code. And then the last one, this is Doom 3, this is 600,000 lines of code. And I don't know, I always think these numbers are interesting, not sure why, but you know, they always say every presentation has to have graphs and numbers and stuff, so this is a table. So sorry. Oh yeah, the nerd rage anecdote. So this is a very interesting story. Has absolutely nothing to do with me. But back in the 90s, Doom, back before Facebook and the other stuff on the internet, social media and stuff, they had stuff called mailing lists and news groups and stuff. And back then, the Doom guys, they had a mailing list for Doom, you know, talking about how you can hack Doom, how you can modify Doom, that kind of stuff. And somebody figured out how the asset loading works in Doom. And asset loading is basically, you have a large zip file. And you basically, a zip file is basically, you know, like a list in Java, for example. And you can't just get something from the list. It's a linked list, actually, you know. You just have to iterate over everything till you find the thing you need. And a kind of a flame war started. This is dumb, this is stupid, this is not the way you should do it. Everybody knows you should put this in a hash map or something. Load it once and then put the indices in a hash map. And then you say, okay, I want, I don't know, the picture of the Doom guy. Then I know from the hash map it's the 5th file in the zip file and that kind of stuff. And a big war started and whatever. And the Doom guys, their reaction was something like, no, we actually tested this and it doesn't matter. But nobody believed them, you know. And what turns out, they were actually right, you know, putting it in a hash map, you have to understand, this was 20 years ago. And 20 years ago, I had a very high-end computer and I had 4 megabytes of RAM, for example. So this was very limited hardware, and putting something in a hash map or whatever, or that requires too much processing power, too much memory and whatever, and it doesn't really do much. So asset loading is a fraction of the level loading. So why would you improve that? You know, why would you improve your level loading from 10 seconds to, I don't know, 9.8 seconds or something? Who cares? So I always found this story very interesting because everybody nowadays, you know, goes to schools, universities and learns computer science, and you just learn, you know, stuff like this. You put it in a hash map and this and that, and then you put it in a hash map and your program is slightly faster, but the code is much more, and people say, okay, but hardware is cheap and that kind of stuff. So I like that story. I just have to say it. I have to tell it. You know, it's interesting telling stories that have absolutely nothing to do with you. You know, it's just yeah, and the great stuff other people did, especially. Yeah. So Doom 3. So that's the name of the project, and as you can see, I have an excellent sense of naming. So why Doom 3? I'm not really sure why. It's just fun. That's actually basically it. I've been working on the project for about 3 years now. It's starting to work. It's very buggy, and shit. Yeah. So it happens. So porting software. It's so let's just skip the porting software actually. So why the boring intro actually, or the awesome intro? So why the reason I'm telling all this is a lot of the stuff, you know, I came across in Doom. A lot of stuff actually that's done in the video gaming industry has absolutely nothing to do with what we do in our day-to-day jobs, you know. It's very different. They have very different requirements. There was an excellent talk yesterday. I don't remember the guy's name, but it's Video Games Are for Idiots. And he was talking about how people develop in the video gaming industry. And one of the things is everybody thinks unit tests are very good, but nobody actually does them. And the reason for that is in a fast-moving environment like a video gaming industry, it's just not very viable, you know, to write a lot of code that has a very large chance of not making it in the final product, you know, and unit tests are duplicate code, actually. So that's the kind of stuff is, you know, it's a very different point of view, you know, and a lot of stuff, so this talk has a lot of C++ in it, and a lot of stuff in C++ that's in the Doom engine, Doom 3 engine, is, if you show it to a normal C++ developer, they will actually, you know, run away screaming or something. You know, it's just bad coding, bad standards, bad practice, and that kind of stuff. But it works for games, you know. So that's the reason for this intro. Also to waste some time, you know. So yeah. So disclaimer: I'm not an expert. I didn't work on the original Doom, that kind of stuff. Whatever. I'm an Assassin's Creed fan, but I really think this is true for programming in general. You know, you just have to try stuff. Don't believe anything. You know, don't take it at face value. So with that. You know, take everything I say with a grain of salt. And so, yeah. So how this talk is divided, it's a bit, you know, so first I'm going to talk about some stuff that I really like in C++. I really liked how they did it in the Doom engine. And it was difficult or not possible to port to Java. So this is a bit, you know, this part is what we would like from, you know, I just noticed, actually. Because the guys from Devoxx, when your talk gets accepted, they send you this template and say you can use our template if you like. But then, you know, you get the template, and then you have another Devoxx there, and some sponsors, and then the Devoxx thing here. So it's weird. Not your problem, I know, but it's weird. So the first thing I'm going to talk about, and I'm running out of time very fast, actually. I haven't really is immutability. You know, so. And C++ has very good support for immutability. And Java has very, very, very bad support for immutability. Most of the immutability in Java is runtime stuff, you know. So you have the unmodifiable list, for example. It throws an exception if you try to do something or that kind of stuff. So it's not really compiler level stuff, you know. So C++ has the awesome keyword const, C-O-N-S-T, const. I think it stands for constant. I'm not sure, but it should. And ironically enough, we have this keyword in Java. It just doesn't do anything. It's just one of those reserved keywords that do absolutely nothing. And we keep hoping, or I keep hoping actually, that we actually use it someday. But the discussion so far, nobody's going to use it actually. So const in C++ is actually a type, you know. So if you have a const integer, so if you look to the highlighted blue line, for example, so there's a const and then there's a vector. You can't actually pass anything to the function except a const vector, you know. And you know when you pass a const vector, it's constant, so it can't be changed, you know. So when you pass it, it's not going to be changed within the function. So I really think that's awesome. And the closest thing I can actually do with this in Java is, you know, just define it as final and just be very, very careful, you know. Because you can still change, for example, a vector has an x, y, and z. You can still change them within the function in Java. C++, you can't do that anymore. So there's not really a direct obvious way or easy way to do this in Java. This is very unfortunate. So I like this a lot. The yellow line, that's my favorite actually. So in C++ you can define a function const. And this basically says this is a read-only function. This doesn't change anything within the what's it called? Somebody help me. Yeah. No, that's not the one I'm looking for. But thank you. Thank you. No, sorry, that's not the one I'm looking for. Oh yeah, so this getDimension is a function within idvec3. And this means this function getDimension can't change anything within idvec3. You know, if you call this function, it will never change something within the object itself. Class was the word I was looking for. Sorry, what? No? So if I say anything wrong, you know, just attribute it to that I have a cold. So the last one, the one in red, this is also one of my favorites actually, is you can simply, you know, like I said, const is a type, so you can also return it. You can return something that is immutable, you know. And in this particular case, I just clone the object and return it, you know. It's an easy solution. Sometimes it's an easy solution. Most of the times it isn't. And I'm going to skip this one, but all right. So yeah, Java has some stuff, you know, final, and final does some weird stuff. You know, it's awesome for some things, but not for immutability. You know, so final for variables. I'm not really sure why we have this. You know, I mean, final references are not very helpful, but okay. Unsigned primitives. So yeah, thank you. Unsigned primitives. So I really like unsigned primitives. I know a lot of people have a lot of different opinions about this, but generally speaking, you know, so actually let's show this one. So Java doesn't have unsigned primitives, and this is actually legal Java code. You know, this will compile. It won't run, but it will compile, because you know, an array takes an integer. You know, an integer can be a negative number. So this will compile, you know, and that's weird. I find that very, very weird. But anyways, so the easy solution to using unsigned primitives for me is to use the next primitive over. So I need an unsigned int, so I need a very large range of positive integers, so I just use a long. And it works for most cases, but sometimes it doesn't. And no presentation is complete without some benchmarks. So I did some benchmarks about using ints and longs and whatever. And it turns out it's not as cheap as people think. So for those of you who've never really made a game is basically an infinite loop. You know, it runs for as long as you're playing, actually. So, but it's basically a lot of infinite loops, you know. So it really does matter how many objects you create. It really does matter how many instances you run and that kind of stuff. And going from something to from an int to a long, for example, it really costs you, you know. And same thing with floating points and whatever, and that kind of stuff. And I know people like big ints and big decimals, and you always hear at conferences, big ints and big decimals are as fast as primitives and whatever, and I really don't think they are. And again, micro benchmarks don't mean anything. They're just there for fun, actually, but whatever. So that's unsigned primitives. This is going too slow. Overloading. Nice picture. Overloading, operator overloading. So Java doesn't have operator overloading. Operator overloading is basically, for those of you who don't know what it is, so you can, in other languages, you can define an object and you can say, okay, if I use the plus sign, for example, with this object, it should do this and such. But this is misused sometimes and people don't like it, so they didn't put it in Java. This line is actually from a paper Guy Steele wrote long, long ago. And he was saying, okay, it's actually a good thing, and we want to add it to Java, but I'm not sure what happened to Guy Steele, so they never added this. So this is how. So operator overloading is used everywhere, of course, in the game. It's you know it's a very you know it's a game, 3D graphics, a lot of math involved, and a lot of vectors and matrices and that kind of stuff. So you have to overload those operators if you want to multiply with vectors or whatever. So so this is how I did it, you know. This is how every Java developer would do it, actually. They might choose different names for the operators themselves. But you know, I did some simple stuff: O operator and a multiply, O plus, O multiply, O plus, that kind of stuff. This is the same actually, but you know, if you replace it with 2 underscores to be Java 9 compatible. And this is actually how it looked in the C++ code. You know, and I don't know, I still believe this is more readable than the whole function thing above. But people disagree with me very much. I know this, but sure. Okay, yeah. I'm giving the talk, so you have to believe me. I think the one below is still the best, and I think operator overloading is also a reason why templates suck in Java, for example. But that's a different discussion. Oh yeah, so this is an example. So another thing with operators in general, you have operator precedence. You know, a multiply comes before a plus and that kind of stuff, and you have to read from left to right or from right to left and that kind of stuff. So how does this work if you use functions, you know? And the same applies for big decimal, actually, but because the big decimal has infinite precision, it doesn't really matter much, but it really does, actually. So, so this is how I would write it at first, you know, but it's actually wrong, you know. This is how you should write it. You know, you multiply B by C, and then you add the result to A. That's actually what happens in the line above in C++. And this is actually what the compiler does, you know. So, yeah. This is tricky stuff. I had a lot of bugs. Somebody asked me earlier, why do you have so many bugs? And it's this kind of stuff, you know, one bracket that is too far or too soon or too near or whatever. So that kind of stuff. Size off. So, sorry, I keep looking to the slides because I forget what order the slides are in. So, but size off. So Java doesn't have an out-of-the-box solution to measure how many bytes an object should take in memory. And it's understandable why, you know. I mean, Java's memory managed, and it's not always the same, and with a lot of overhead and that kind of stuff. But I mean the basic stuff, you know. So if I have an object with 3 integers, I know an integer is 4 bytes, so it should be 12 bytes, actually, you know. It's not very true in Java, but it's very, very true in C++. And it's very used in C++. And it's very, very used in OpenGL. And this is, okay, this is a wrapper around the OpenGL, but it's OpenGL. And you need a lot of this stuff, actually, to make OpenGL operate. So my solution for this was to implement a bytes static final int for every object. This is actually what Java does. So if you do integer.bytes, you will actually get this. You will get 4 bytes, or is it 4? It is 4. You'll get 4 bytes back. And it basically looks something like this, actually. Technically speaking, this is actually faster than the C++ solution. It's just a lot of work, because this is something you do once, but size off, every time you do size off, you have to calculate the size. So it's very important for this kind of stuff in the game. Again, this might seem trivial for everybody, and you know, I do web services and I do, you know, enterprise applications, and I never use this stuff. So that's why I wanted to disclaim people at the beginning. If you only read the title of the talk, don't really attend the talk, you know. So destructors. So another cool picture. So destructors. Java doesn't have. It actually has destructors, but they're not very used. You know. So Java has what's it called? Finalize, which I think is deprecated. I'm not sure. I know there was a proposal to deprecate it. Is it deprecated? It's deprecated. It's still there. It doesn't really do anything. It does exactly what you want it to do. It just doesn't do it when you want it to do. You know, that's the problem with finalize. So destructors, generally speaking, destructor it's the opposite of a constructor, obviously, and you want to free memory in a structure or free resources, that kind of stuff. In C++, that's very important, because C++ you manage everything yourself. In Java, everything is managed for you, so what's the point? The problem with this argument is a lot of people misuse destructors or deconstructors. I'm not sure which one is correct, actually, but destructors. So this is an example from the game, you know. This all happens within a destructor, you know. And yeah, so I can't put this in a finalized method. I could put it in there, but it might never run. It might run, I'm not sure. So yeah, I just opted to create a function and just call the function. It's not very hard, but most C++ developers would actually not think of this as good code, but it works. And you let the machine or the compiler just do the work for you, which is what you want actually. It's the same thing which we do with the JVM. The JVM does a lot of work for us. Sorry. And yeah, Java has some other stuff like auto-closable, which was a good idea, but you always have to use it, try catch and whatever. And so, okay, let's skip enums for now. Inheritance. So I thought I actually removed this one, but okay. So a common pattern in games, not in games actually, but in this game, is you have a lot of inheritance. And the common thing you do is you could have an object that inherits an object that inherits an object, and you want to call the super.super function in Java terms. And this is impossible in Java. And I'm not really sure. Actually, I kind of know why, but it's just weird that it's not possible in Java. In C++, you can just do this. So this is, this class inherits from this class, and this inherits from the 8AF and entity underscore base class, and you can just call the function this way. So yeah, how did I solve this in Java? I just made an 8AF entity base think function within the middle class, and I can call it from the middle class and that kind of stuff. It's not very beautiful code or whatever, but it works. And I don't know, it annoys me. And it also annoys me that equals and hash code are inherited, but like I said, I thought I removed that because that's a very long rant. So yeah, that's it for inheritance, I think. So yeah, I was too cheap to buy this picture, so that's why you have the big ugly watermark there. But I think everybody can read it, and I kind of like it. So pointers. Pointers are awesome. I know people hate pointers, and I know people don't. Pointers get a very bad rap, and I know when I started, when I took programming classes in school, people were only dissing pointers and whatever, and Java was new back then, and everybody said, hey, Java does everything for you, you never need pointers again. It's true, you don't really need them, but they can be very helpful. And you have to remember, your computer works with pointers, on a fundamental level, on the electronic level, your computer has pointers. So it's very helpful to be able to simulate your computer a little bit. And so this, for example, the above function, you get 2 pointer parameters, and you can assign the... So this is basically, if you have a function that has more than one return type, which is impossible in Java, and other languages have this, but Java doesn't have it. And C++ doesn't have it either, actually. And C++ solves it with, okay, you just pass 2 pointers or whatever, and just assign them. How did I solve this? I just made 1-element arrays. I have a lot of 1-element arrays in the code, and it's basically just poor man's pointer, actually, like I like to call it. And you just do this kind of stuff, and you still get, kind of pointer-like behavior without very convoluted code of putting something within an object or whatever, or references or whatever. This is another one. You can, with pointers, you can basically just cast pointers to cast anything to anything else. So this is basically a class with a lot of floats, and you just cast it to a float pointer, and because this class has 9 floats, this will give you a float pointer with 9 positions back, actually more. And how did I solve this? Just create a new float array and very carefully hope that nobody wants to change any of these values, because you can't change. This is basically an immutable array which you send back. You can change the values, but you can't change anything within the matrix itself. Yeah, skip this one. Oh yeah, and this is the funny slide actually. So why does Java have null pointer exceptions without actually having null pointers? In general. So yeah, no, weird. I'm not sure. Okay. This part is actually the other way around. Stuff that I don't really love it in Java. It's just that Java doesn't have it, and I think it was the correct decision not to implement this stuff in Java. Macros. So there was a project actually about, I don't know, 10 years, 15 years ago to introduce macros to Java. And thankfully, it never succeeded, actually. And macros is one of those things, even the C++ guys, the architects of C++ hate macros, but they're so intrinsic in the language that everybody uses them, and it's very difficult to remove them. So a macro is basically you can define a piece of text, and it will be searched and replaced within your program. That's basically it. And this is literally actually it. And this happens before compile time. This is a preprocessor process. And it's very error prone. A lot of IDEs don't. Okay, nowadays more IDEs support this kind of stuff, but in the early days, a lot of IDEs didn't support it. It's very hard to debug this kind of stuff, and like I said, it's very error prone. So this, for example, is a very simple macro. You say, square this and whatever, and I'm very certain none of you thought, not none of you, but most of you didn't think this would be replaced with this. I didn't know that actually. But this is a common example they show on the internet for why you shouldn't use macros. And this is another common example. So this is actually from an article called Death by Macros, hence the title. And this was a piece of code that they would show anybody who would abuse macros. And for those of you, so here I highlighted actually where the macros are. This is an actual piece of code. This is from a Linux shell, one of the Linux shells. And yeah, this is very bad code, or very, very hard to understand. So yeah, the game has a lot of macros, And this, for example, a very simple macro. And this unrolls actually something like this. And my biggest problem with this is I didn't see a lot of this stuff, because you can place macros anywhere in the code, actually, and they have a weird kind of scope. So you might not necessarily see it at first, that this macro is for this class, especially not in something this big. So I missed a lot of these things, but later I implemented them. So the implementation itself is not a big deal, but macros are evil. So thank you. Yeah, people actually understand this. Thank you very much. So usually only C++ developers understand this one. So C++ has something like, the same way camel case is religious in Java, C++ usually has something called Hungarian notation. And this is a Hungarian notation. This actually means HWND means handle window, and this is the handle of a window. Hence that is kind of funny, but not when I explain it. So Hungarian notation is very weird. I didn't really have much trouble with this in the game itself, but it's still in there. And when it's in there, I usually have to go up on Wikipedia or C++ references or whatever to understand what this actually means, that kind of stuff. So this is simple Hungarian notation, and people actually use this. People still use this. So if you have, for example, I don't know, a class foo, and it has a member bar or whatever. In C++, people would call bar m_bar, because m is a member of a class, and it doesn't really make sense to me, but okay, whatever. And p means pointer, and sz means, it's a string, and it's 0 terminated, null terminated, or whatever. And then you get the name, and that's the actual name of your field. So Hungarian notation is also very evil. I'm very thankful that Java people don't do this. Most of the code in Doom is actually camel case, so that's also very good. But it's still in there, and Oh yeah, this was a funny quote. You can look it up later. There's a lot of rants about Hungarian notation. Thank you. Oh yeah. So this was about Hungarian notations, but camel case can also be very evil. So the one above, that's an actual class name in Java. I think they removed it, but it was an actual class name. And this Stack Overflow post was actually removed. I'm not sure why, but I got it via the Wayback Machine. So this is awesome. This is really awesome. I'm not sure who this guy is, Peter Lorre, but you're awesome. So that's that. Yeah, unions. So union, I'm not really sure. So C++ existed since the 70s. I'm not sure. I'm not sure since when C++ existed, but I'm sure it exists. It started out sometime. Okay, let's go back. C. This is actually unions are from C, and C is very old. And back in the old days, you had limited memory. So somebody came up with something called a union, and it's basically you can define sort of an object, and the object only takes limited amounts of memory, and all the members overlap. That's basically it. So here, this is a simple example. You have an IP address, and within the IP address, you have a struct, which is a lazy class, or a class with nothing. And you can, you define a couple of chars, but they overlap with the integer IP address itself. So you can, read the IP address or read one letter of the IP address and that kind of stuff, which is, I don't know, could be helpful. I was telling a friend of mine about this, and he sent me this screenshot from a book. It's one of the usages of unions for registers, CPU registers. CPU registers are divided into smaller registers or sub-registers or whatever they're called. Okay, no, it's also a good usage for unions and such. This is actually one of the worst parts of the code that I had to port. So yeah, this is from South Park. It's Inception. Doesn't matter. But a union within a union. So this is a union within C++, within the Doom engine. And I'm not sure if I can use a pointer here. Can I use a pointer? Yeah. So if you look here, the union references itself within the union. It has a pointer to a union with the same type. This was plain evil. I'm not sure why they did this, And I ported this. It took me about 3 months to port this single union. I'm really not sure why they did this. There are stories about developers that at the beginning of a project they would reserve some memory, for example, and in the old days, when memory was expensive, and they would reserve some memory to to push all the developers to use memory as efficiently as possible. When nobody can go any further, they would, here, let me free some memory for you. I think this is that kind of thing. This is really some kind of hazing stuff. I really don't know. And a lot of these fields are actually not used within the game itself, so I'm not sure why they did this, but it took a lot of time. Unions are also very evil, I think. They might have their usages, but I'm not sure what they are. But again, I'm not a C++ developer, so who knows? Yeah. So yeah, this is a list of something in between, I think. It's not basically, it's stuff Java doesn't have, but yeah, it's not very essential. But so Java doesn't have default arguments, for example. I'm not really sure why. This is very simple to implement, I think. It's very, it would make your code much more readable. So this is the above example, that one line, and this is the simplest way I could define it in Java, for example. It's, I don't know, 6, 7 lines or something. Why don't we have this? I'm not sure. So, sorry? No? No? So yeah. Inlining. So Java doesn't have, it does have inlining, but the JVM does it for you. You can't force it to inline something. You can, but it's not easy to force the JVM to inline something for you. In C++, you can just, underscore force inline, and it will force this function to be inlined everywhere it is called. And again, this might not seem as important to our day jobs, but a game is an infinite loop, and you call methods thousands and millions of times or whatever and such. And you would think that JVM would always inline that kind of stuff. I hope that JVM does it, but I would like to be certain, I know this function has to be inlined because the original Doom guys inlined it, and they're smarter than me. So I would like to inline it. So Java doesn't have an easy way to do this. Also, something I think a lot of us could benefit from. Right? Yeah, so this one. So everybody has done this at some point of time. You want to concatenate 2 strings, or you want to insert a string within another string, and you have to do some substring stuff or whatever. Or if you're much more fancy, you would use string utils or that kind of stuff. And the equivalent of that ugly line of code above is that code below in C++. And it's really mind-boggling why we don't have that kind of simple stuff in Java. It's very basic stuff. People do string manipulation all the time. So why is it so hard? And some people use string buffers, string builders, and whatever, and those things are very expensive. So why? I'm not really sure either. So that's why this is a wish, nice to have list. Very simple, I think, to implement. Again, I'm not an expert. I'm not a JVM architect or one of those awesome guys. So it might be very, very hard to implement. But I don't know. It seems easy. Everything seems easy when you don't have to do it, yeah? So, I'm actually okay on time, so this is awesome stuff in C++. That's very, very hard to do in Java, I know. So in C++, because you have pointers and you have memory addresses and you have stuff that doesn't move around in memory, you can actually watch your memory address. And what that's helpful for is, for example, you have, I don't know, a vector and somebody changes it. But the vector has, I don't know, something like 200 references or such. And you want to know which reference, changes the vec x variable to 1.76 whatever. And in C++ you can just watch it. And as soon as somebody changes that memory address, you get the breakpoint goes off. In Java, it's much harder. It's nearly impossible actually, or I thought it was nearly impossible, but the fine guys of IntelliJ implemented this, and I'm fairly certain most people don't use this. It's a very helpful feature actually. Sorry? No? Yeah. The only problem with this is it's very, very, very slow. It exists in IntelliJ. I think it has existed in IntelliJ for 2 years or something like that. And actually, yesterday I walked to the IntelliJ guys downstairs and I asked them, why is this so slow, And I got a very unfortunate answer, is the JVM TI is slow. This has nothing to do with us. I thought they implemented a very fancy feature in IntelliJ because as far as I know, Eclipse doesn't have this and NetBeans either. Correct me if I'm wrong, anybody? But so this is basically JVM TI's, I think, tools interface or something. That's basically where the debugger and all that fancy stuff we use in Java comes from. And this is one of the features. Nobody uses it because I don't know why, but it's just very, very slow. But again, this is slow for my purposes, for the purposes of the Doom game, For the purposes of your day-to-day job, once again, or my day-to-day job, this can be helpful, So from the 100 times I've used this, it actually was useful once, and it wasn't for the game. It was for just a Java enterprise application. So setting it up is a bit annoying in what's it called, IntelliJ. You have to know the number of your instance and the exact field and that kind of stuff. And usually you know that stuff, but it's much more annoying than just doing that. What you do in C++. Yeah, so another feature, I'm not sure a lot of people know about this. This is a very old feature, and most IDEs support it, but you can just pop the call stack, So if you're within a function, you can just pop that frame and you go back to the frame before that. The problem is if you change any state outside of the scope of the function within that function, it doesn't reverse that state. But it's a very helpful feature. I use it a lot, everywhere, in day job, night job, anything. So this is the GDB, C++ equivalent. Now it's not C++ actually because this is from GDB, but you have something called the reverse step. So the same way you step into something, you can reverse step out of something, and it just turns everything back. Granted, this is not 100%. It's really not 100%, but it's much better than what we have. I think a while back there was a debugger called Chronin, something with Cronus in the name. They tried to do this, but I never got it working, and they're also not free. So maybe it does work. I have no idea, but this is a very nice feature. Oh, hello. Yeah. This is a nice feature. I think we would benefit from a lot. Okay. Yeah. Yeah, I usually skip this slide, but so Java has this. We had this is 5.1.2. That is actually the number within the JVM spec, actually, of the widening primitive conversion. So this is actually something documented that this happens, and it's very weird that it happens without warning. You can put a float within a double, and the value may change, and you will get no warning. You can put a long within a double, and the value will change, and you will get no warning. And it just happens. It's very error prone. And I've had a lot of bugs, you know, around this stuff with doubles and floats and such. These are some examples for you know, if you look at them, they're very, very simple. You would expect them to not change, but they do change. So again, not sure why I'm telling you this, but I'm here, so why not? So yeah, this is related to the one I told before about operator overloading, and you have operator precedence. So why is operator precedence actually important? You know, for certain operators. So, example, the one on the left, it's, you know, it's multiplication and division. You know, and as we all know from math class, it doesn't really matter in what order you do the multiplication and division. It matters a little, but it doesn't really matter, generally speaking. But for floating points, it does matter. And the reason for that is very simple. Floating points don't have infinite precision. They have a very limited precision. And the order you do things in can change the precision. So the one on the left with the multiplication and division, I think, I don't remember which, but either BLA1 or BLA2 actually produces 0, and the other one produces an actual result. You know? And it's strange. It took me a while actually to find this bug. This is an actual bug in the Doom engine. Oh, sorry, the one on the right is the actual bug in the Doom engine, but it's the same concept actually. But yeah, it's very hard to find, and you know, C++ has this as well, and Java, everybody has it. This is an IEEE standard thing. It's just very annoying, and again, a warning would be nice or something. And the one on the right, yeah, you wouldn't expect this to go wrong either, actually. But it's the same concept. You don't have infinite precision. You have very limited precision. So if you add things, you know, if you have the brackets, so you add them first, and then you subtract them from A, or you subtract everything in that order. So it makes a lot of difference for the precision. And yeah, this one, like I said, this one is in the engine itself. The problem, well, it's not a problem actually, but why it's not a problem in the engine is because it's constant, you know. So they have a different class where all the classes make this, all the functions make this error. And if everybody makes this error, it's an acceptable error actually. So yeah. Yeah, conditional breakpoints, another micro benchmark. If you haven't noticed, I hate micro benchmarks. People always, you know, use them and they mean something, or people like to say that they mean something. They don't mean anything actually, except that this simple test is much slower if I do a conditional breakpoint instead of not. So conditional breakpoints are basically when you make a breakpoint and set a condition within the breakpoint itself, you know, in IntelliJ or whatever your IDE is. And again, a game is an infinite loop. And infinite loop, you do a lot of, you know, if you put a breakpoint in there, the breakpoint gets tripped a lot, you know, so you have to check the condition every time. So I made it a very simple experiment. The first experiment is I set this condition in if statement, and within the if statement I set a breakpoint, and you know, every time it gets tripped, a normal breakpoint, you know, I just measure the time. The other one is instead of the if statement, I remove the if statement, and I just put the condition of the if statement within the breakpoint itself. And it turns out, in my experiment at least, the conditional breakpoint is about 180 times slower. So I'm very sure this number isn't accurate. I know it's slower, but not 180 times, because that's ridiculous. But you know, I made this slide, and you know, I was too lazy to change it and measure it correctly. And I use basic stuff. I don't really use micro benchmarking tools or whatever, just system printouts and that kind of stuff. So you know, this is something I discovered. I didn't know about this. I discovered it while I was porting the game, and I thought it was very helpful to tell you fine people. So this is the last slide, and this is right on time actually. So yeah, backwards compatibility. So I had a very annoying bug. The screen on the left was the not correct one. The screen on the right is the correct one. If you look on this very fine big screen, you can see that the screen on the left is very blue, you know. And I couldn't understand why it was blue. You know, I thought it was a very simple bug, you know, something like, I don't know, something simple. I can't really think of anything right now, but I thought it was something simple, you know. And it was just, this was very early in the game, so this was the first time I was getting a working screen in the game. I was so happy. you know. So I just ignored it, and I thought, okay, it's a simple bug. Actually, at first I didn't even notice that it was blue. I was so happy that I didn't notice it was the wrong color. But that's a different story. So so yeah, I thought this is a simple bug. Let's just do it during downtime. So when you want to change pace and you fix a simple bug to give yourself a good feeling, that kind of stuff. I thought it was very simple, but it took me about 2 weeks to figure out what it is actually. And what it is a very simple something actually. Is for this I use byte buffers, and byte buffers are awesome. If you never use byte buffers, they're awesome. But they have a very big problem. Is if you duplicate the byte buffer is basically a class with a bytes array underneath, and you can do very fancy stuff. You can do something like put an int in there and then get the bytes back and that kind of stuff. And for this kind of manipulation, it's very easy. And for a lot of OpenGL stuff in Java, it's necessary actually. It's just forced upon you. So for this part, I was using a byte buffer. And I was doing a lot of duplicates on the byte buffer. It's basically a clone method, but for the byte buffer. And what turns out, when you do a duplicate on the byte buffer, the byte buffer ignores which endianness you've chosen. Yes, so the people who made that sound right now, yes, thank you. So most of the stuff was little endian, I think, and when I did the duplicate, it reverted back to big endian, and it's basically just flips the bytes around, and this is RGBA, red, green, blue, and alpha, and it just gets twisted around, and you get this blue tint. So it was very simple. It wasn't simple to find. Yeah, did I? Oh, yeah. So I went on the internet and I searched, why is this so? And everybody says, no, it works as expected. This is spec. This is according to spec. And somebody made a bug on the Java bug board or something. I'm not sure what it's called. And one of the architects, I think, or one of the guys involved, he replied, no, this is as expected. It should work this way. And the bug was closed. It wasn't until a couple of years ago I went to an Ask the Architect session. Like the one being held today, and I asked the architects, great architects, why is this so? And I finally got my answer. This is actually a bug, but it's been in there so long, and not many people are complaining about it, that they just have to leave it in there. So that's why it's a backwards compatibility story. So this, you come across this kind of stuff a lot in Java. It's annoying. I hope it changes one day. I know it won't, but I hope. I can still hope. And that's it. Questions? Yes, sir. Sorry? Okay. Yeah. If I can find my pointer. Yeah, there's my pointer. Not yet. No, not yet. So the game isn't fully functional yet. It's kind of functional. Yeah, I'm not done with all the bugs yet. Right now, yes. So right now the code is basically just the C++ code, but translated to Java with some fixes here and there. So my plan was at a certain point in time to actually translate, rewrite a lot of stuff for Java, because a lot of stuff that's performant in C++ doesn't really matter for Java, and vice versa. Any other questions? Because this takes a while. Slightly less, because a lot of the code in the C++ version is, for instance, has a lot of assembly in it. And at first I was really, thinking about porting that, but then I thought, no, I won't port the assembly code. It's too hard and such. Any other questions? This will still take a while. No? This level. To get it started, so the blue screen, which I showed, so that was when it first started to work. That was about, I think, a year. Yeah. And this is actually what I'm showing right now. This is an older build, because my current build doesn't build. And yeah, so compile time. Oh, it's very fast. It's Java. So, yeah, that's one of the advantages, you know. When I first checked out the C++ code, I started building it without multiprocessor support, which is something is not on in default, by default in C++. It took like, I think, 20 minutes to build or something, or 25 minutes. Now it takes about 5 minutes. But in Java, it takes, I don't know, 1 minute, half a minute. Yeah, so everything is in wireframe because I still have a problem with the lighting, and I didn't show the wireframes, you wouldn't see anything. You would, but you have to, you know, get very close to the screen, which is difficult. And you can see the guys are a bit mangled and whatever, and flying heads like that one, and such. You can actually see it right here. Yeah, it's supposed to look that way for people who haven't played Doom. Yeah. The sound was actually working better than this, but I broke it somewhere. And like I said, it's an older build, and I can't remember which build I fixed it again in, so I just leave it at that. Yeah, I have a lot of problems with versioning and that kind of shit. Oh yeah, so now we are within the game, I think, I hope. Am I within the game? Oh, okay, it froze. So this happens during demos, of course. So this screen says I'm out of time. Thank you very much.